if I were to just make one up, oh, this is by a long shot. Can you guys help me with this? What number am I on? 6. Number 6. I better not. I want to be consistent. I want to get some good examples. How about 2 minus 4 cosine theta? Yeah, that'll work. So you guys, I don't know how you were raised in terms of sketching these polar graphs. Personally, I do not plot points. If you do, that's fine. Do not make me change your ways. Personally, when I talk about polar graphs, I mean sketch that thing in the xy coordinate plane. Now to sketch that curve in the xy coordinate plane, r and theta have different interpretations. Theta is the direction I look at from the pole. In other words, it's the angle I make with the polar axis. And r is simply how far I travel in that direction. You guys have heard the old arguments, haven't you? I'm in New York City, I'm standing right here, I want to travel to this corner over here, but I'm in New York City. And if I hail a cab, the cab's got to have to travel horizontally and then vertically in terms of my picture, isn't it? And so the location of this point is going to be x comma y, where x is my horizontal distance traveled, y is my vertical one. But can you imagine what would happen if I stepped off the curve when the taxi was coming, and the taxi didn't see me, and it hit me, and it killed me? But I still want to get there. Wouldn't I just look in the direction I want to, and simply walk that distance? It gives me the same location. It's just a different way of identifying how to get from that corner to this corner. I might refer to this as a polar representation of that position in my Cartesian coordinate system. Personally, I like to use brackets so you, the reader, understand these are polar, not rectangular coordinates, but that's what that's all about. To sketch that curve, I'm tired. I'm lazy. I have a tendency to not sketch this polar graph first. I have a tendency to sketch this rectangular graph first. And when I say rectangular graph, I mean graphing r against theta. Because I think in the r theta plane, this beast right here is nothing more than a very simplistic sinusoidal wave. And I think right now the sinusoidal wave has period 2 pi. Maxes out at 1, mins out at -1. But now it maxes out as an inverted cosine wave at 4 and mins out at -4. But vertically translating that 2 units up, now I maxed out at 6, min out at -2. See, I said max out at 6. Min out at -2. I said the period's going to be 2 pi. That means my median r value is going to be positive. And it's an inverted cosine wave. So I know I'm going to start at my local min r value, which is right there. One full cycle through, I'm also going to locally min out with my r value -2. But halfway through, I'm going to locally max out. Both 1/4 of the way through and 3/4 of the way through, I'm going to hit my median r value of +2. And I think my sinusoidal wave looks something like this. Do you guys agree? Only because I think it might be interesting. Do you guys mind, before I go over there, can I just take a short break and identify these theta intercepts? See where I cross the theta axis. Phi is equal to 0. Cosine of theta is +1/2. I think the cosine of theta is +1/2 when theta is equal to... You guys can do this. I know you can. Theta is equal to... The cosine of theta is equal to pi house, and theta is equal to... thank you. Or 2 pi. Say it again. 4 pi. In the fourth quadrant? Yes. Okay, as long as you're okay with that. Well, you know what? I might need that. Can I dive in here and just talk about those 2 angles? I said, what did I say? Pi thirds? And 5 pi thirds? There they are. And I'll unitize my axes in terms of 2's. And it is time to play. So everybody, look at my first rectangular graph r against theta. Is it not true that as theta increases 0 to the blue pi thirds, my r values increase from -2 up to 0. Let me say that again. As theta rotates from 0 radians to pi thirds radians, my r values increase from -2 all the way up to 0. I think, graphically speaking, I'm spanning out a portion of my curve that kind of looks like this. I think as theta continues to rotate from pi thirds to pi halves, my r values continue to increase from 0 up to +2. So rotating from pi thirds to pi halves, r values increase from 0 up to +2. As I make 1 full quarter rotation from pi halves to pi, look what my r values do. They skyrocket. They jump from 2 up to 6. Oh, I'll say that again. As I continue to rotate from pi halves to pi, my r values shoot up from 2 all the way to +6. I might be exaggerating with my curve. I'm not that good of a drawer. I think as theta continues to rotate from pi to 3 pi halves, my r values start changing direction. They now decrease and 6 down to 2. So rotating from here to here, my r values decrease from 6 down to +2. However, for a small amount of rotation from 3 pi halves to 5 pi thirds, my r values continue to decrease from 2 down to 0. So as I rotate from here to here, r is decreased from 2 down to 0. And finally, as theta continues to increase from 5 pi thirds to 2 pi, my r values become more and more negative. Until I finally complete 1 full revolution at 2 pi, my r values are as negative as -2. There's my Lima song.
So wouldn't that, in the fourth quadrant, isn't that a tangent line?
Yeah, I didn't do a very good job. Technically speaking, what you see in blue ends up being a tangent line to my curve.
Okay.
As a pass through that origin. Sorry for my sloppiness. Are you guys aware that if you go to the math website, there's a pull of graph paper there for you to use if you want? I gotta remember this. If you need this in exam, the final exam, I'll bring it in. Oh,
Are you gonna have like a polar graph for us to use to chart? Or
a pull of graph paper.
Graph
I think
this.
what I'll do is I'll just bring in a stack of them. You just attach it to your exam if you want to use them.
Okay.
You guys, we had a conversation last week, and I don't remember what the answer was. What are we having on Wednesday? What test?
New stuff Wednesday.
So new stuff on Wednesday, old stuff on Thursday.
Yeah.
I don't care. They're both sent to the printer. I just didn't remember. You guys, give me some feedback. It's just curious for me to know. Did you guys draw rectangular graphs before you did polar graphs or not?
No.
No.
Is there a show of hand? Did anybody do it this way?
Well,
Sorry, I'm not being very clear, Randall. Well, you don't have to answer this question. I know you. I'm asking, when you were raised trigonometrically speaking, did you sketch rectangular graphs before you dove into this?
we didn't do that.
What did you do? How did you guys graph these things?
Plotted points.
Wow, really?
Yeah. That's basically what we did to graph these things. Plotted points.
And you took this here at Sierra College?
Yeah, but we did do the transition from rectangular to polar, but we didn't do it with the number line or the
You guys, I'm coming to class and I'm beating the clock. And I told you I'm not going to review this. Well, maybe one example, but you don't have to graph these my way. On the exam, you can graph it any way you darn well please.
I think your way makes a lot more sense.
I like my way only because I can smoothly talk about how the curve is changing. Instead of plotting point here, here, and here, and say, oh, gosh, I think this is what happens in between. I just don't like plotting points. I don't know what's going on in between these sides. I make arithmetic blunders all the time. So you do it whichever way you like. That's just my approach. But there's something I have not yet mentioned, and that is the following. As I think when it comes to polar graphs, x and y could be interpreted this way. But what would happen if you and I treated r as a function of theta, which, by the way, with that example, r is a function of theta. Don't you think the x and y coordinates can be interpreted this way? Over there, treating r as a function of theta, I'll use this language. You know what this suggests? It suggests that maybe I can think of x and y parametrically in terms of theta. All this polar garbage you guys were trained to deal with back in trigonometry was silly business in the sense that it's just nothing more than a parametric way of representing a curve. And if it is, let's see how we can talk about slopes of tangent lines. You know what I'm going to do. I'm going to think of dy dx as dy d theta over dx d theta, treating theta as my parameter. But that gives me a fraction where upstairs dy d theta is. Let's check it out. Let's compute dy d theta. Got to use a product rule. I think it's dr d theta times the sine of theta plus r times the cosine of theta. I think another name for dx d theta is going to be, oh shoot, look up here, I better use a product rule. I guess I get my dr d theta times the cosine of theta minus r times the sine of theta. Here is how you guys are going to be computing slopes of tangent lines for parametric curves. I said parametric, I take that back. Here's how you can compute slopes of tangent lines for polar graphs. So you guys, let's see what happens in this picture. Let's see what happens in my picture. When theta is equal to pi halves. Are you guys ready? Because I think dr d theta from this equation is nothing more than, I really don't know you guys, I'm serious. Is that a positive 4 sine of theta? So to answer my question, dr d theta, evaluate when theta is equal to pi halves, simply gives me 4 times the sine of pi halves, but that's just simply 4. Man, did I mess up my picture? That's a positive number, but clearly when theta is equal to pi halves, the slope's not positive, it's negative. What happened? Did I make a mistake?
No.
I did not. I didn't make a mistake. I just think that's not the slope of the tangent line. This is dr d theta when theta is equal to pi halves, which means it's how r is changing when theta is equal to pi halves. And I think as I'm rotating past pi half before and after, my r values are increasing. They're getting bigger and bigger and bigger. And that's why I think the value for dr d theta is positive. That does not represent the slope of the tangent line to this graph when theta is equal to pi halves. I think to come up with the slope of the tangent line to the graph at theta being equal to pi halves is simply generated by looking at this means by which I compute slopes of tangent lines. You guys, let's do it. My first factor in the first term is dr d theta at pi halves, but dr d theta at pi halves is positive 4. Times the second factor of the first term upstairs, that's the sine of pi halves, but sine of pi halves is just 1. Plus, my r value when theta is equal to pi halves, I really don't know what that is. Is that 2 minus 4 times 0, which is 2? Times the cosine of pi halves, that's just simply 0. Downstairs, dr d theta when theta is equal to pi halves, I've already computed. Times the cosine of pi halves, which is 0, minus r when theta is equal to pi halves, which is 2, times the sine of pi halves, which is 1. I think my slope of tangent line ends up being negative 2. Oh, you know what? That doesn't make sense in terms of my picture. But I'm here to shake you guys up. I need you to understand why this number and this number are not the same. This is the slope of the tangent line when theta is that value. This is dy dx. This is not the slope of the tangent line. This is how r is changing with respect to theta when theta is equal to pi halves. It has a completely different meaning. Okay.
So what would be the 4 represent as far as
What would you, I'm sorry.
that 4?
I think the 4 represents that as I'm spanning through just before and just after pi halves as an angle, when I'm sketching the curve, my r values are increasing at 4 units. Exactly what theta is equal to pi halves.
I see.
So is that the slope of the tangent line on the x?
Well, when theta is equal to pi halves over here, I have to confess, I really can't think of the slope of this tangent line truly as drd theta.
Right.
And notice I'm careful to label my axes. That's why I can be able to say, yeah, it's gotta be the case. Tyler.
Can you explain step 2 again, how you got drd theta?
It was this easy. I want you to come back to my original equation and just differentiate both sides of spectrum theta. Is what I did. Derivative of the constant goes out to 0. Derivative of the cosine is negative sign, so I change signs. So Tyler, I was just saying derivative of the cosine of theta is negative sine of theta, change my sign on the outside. I'm just shaking you up to make sure you understand the distinction between these two circle numbers. This is how r is changing with respect to theta at that value of theta. This is the slope of the tangent line at that particular value of theta in this rectangular graph. I said rectangular, in this polar graph. So bless you. Anybody else? Wow. I feel so free today. So I've talked about slopes of tangent lines. I've talked about how you can compute them. I'll let you guys get some more practice. How about this? Can you guys go back to trigonometry for a minute? Or high school geometry, whatever you want to call it. If I have a circle whose radius is r, its central angle whose measure is theta. By the way, measured in radians. What do you think you can say about the area of the circular sector? Say it again.
R squared.
Well, how about in front? You'd have a 1.
1 over pi, 1 over r,
1 over
1 over
2.
2, pi,
R.
r theta,
Did I want
r squared theta.
R squared theta. Thank you very much. Thank you. Did you guys hit this? All right, never mind. Don't listen to me. I got an idea. I think the ratio of the area of the circular sector to the area of the circle itself should be the same as the ratio of the amount of rotation for the circular sector, the amount of rotation for one full circle, which is just 2 pi. It's just that the way you and I compute the area of the circle is just pi r squared. Now, if I took that equation and multiplied both sides by pi r squared, the area of my circular sector, as Randall just stated, is going to be nothing more than pi, or theta over 2 pi, times my pi r squared, if I can write it correctly. Oh, sorry, he didn't say this. He counts the pi's first. And the area is just 1/2 r squared theta. Now, do you believe me?
How did you go from pi r squared equals theta over 2 pi?
Listen to my words in English. I was saying this. Seems reasonable that the ratio of the area of the circular sector to the ratio of the entire circle is the same as the ratio of the amount of rotation for the circular sector, that's just theta, to the amount of rotation for one full circle, but that's just 2 pi radians. I know it's not directly akin to, I know it's not directly using our similarity properties for geometric figures because it's a circle, not a polygon, but I think the same idea applies. So will you believe me now that the area of a circular sector is 1/2 r squared theta? Good. Now, in the Cartesian coordinate system, that is to say, in the xy plane, if I've got some polar graph, and I take theta equals theta naught to theta be equal to theta sub n and gosh, what's a favorite phrase from Math 30? I regularly partition into n subintervals. I think my arbitrary ith subinterval will look like this. Theta range from theta sub I minus 1 to theta be equal to theta sub I. And I think I can approximate the area here by looking at the central angle, whose measures a small change of theta, times the radius squared. But if the area of the small sector is gonna be 1/2 r squared change in theta, then I think the area of the whole region from theta sub naught to theta sub n is just gonna be the limit of a Riemann sum, which in the end gives me 1/2 times the integral from one theta value to another of my r squared, differentiating with respect to theta. I said differentiating. I mean, I'm integrating with respect to variable theta. Theta is my variable integration, and r is a function of theta. This is going to be the means by which I can compute the area within a given curve. So you guys, take a peek at my last example. As theta ranged from, say, I don't know, how about just pi half to pi? Let's see what the corresponding areas that I span out. And I think to generate that area, I'll set up my interval. I think the area is going to be 1/2 times the integral from one theta value to another of my radius squared, and I'm going to integrate with respect to theta. Oh shoot, I forgot what my radius is. I guess my r is described that way in terms of theta, namely 2 minus 4 cosine of theta.
Is that theta between pi or?
Can you say that again? I'm sorry, I just missed it
You
again.
confused me for a second. I think you meant.
Sorry, as theta, I said English, but I didn't write it. Ranges from pi half to pi. Thank you. Tyler.
Do you have to subtract the little r because it's counted twice when you?
Good point. To be honest with you with my question, no. To be honest with you, as theta ranges from pi half to pi, I'm just computing this area right, jeepers. I said this area right in here. Because I think that inner loop was generated by looking at values of theta outside this interval. So I'm only looking what's bounded within my r function theta as theta ranges from here to here. So it did not take into consideration what's being taken away by the interval. I want a yes or no answer, you guys. You have your final exam this week. Is that a piece of cake to integrate?
Yeah.
It is, isn't it? You would first, you would first.
Separate
Or maybe just
No.
FOIL it out.
First FOIL out.
Yeah.
And the first constant's a piece of cake. The second term involves cosine is a piece of cake. The third term is cosine squared. What do you do with it? Half angle or double angle identity. To me, they're the same. And you just use that reduction of order formula. I agree. Do you mind if I don't? Okay. Be honest. Something else interesting. What was I going to do? Got it. Got it. Got it. Got it. Shoot.
So what section are we in right now?
You know, I really don't know. I didn't read your book.
I think it might be 10 point, yeah.
Because I think I skipped maybe 10.3, which is sketching polar
Yeah, I
graphs.
think it's
That's just trigonometry.
Four, right?
I could be wrong, I'm sorry. Whatever section's titled,
We're in 10.3 right now.
whatever section's titled calculus of polar coordinates.
Because I don't think this is 10.2.
And I'm sorry, you guys, if I can't remember off the top of my head.
10.2 is polar coordinates. 10.3 is
I wrote it down.
calculus of polar coordinates. Would you say we were skipping this and going straight to 10.4?
Yeah, 10.3 is a graph, is calculus of polar coordinates. 10.3 is what's important. That's where I'm at.
So are you going through 10.4 still tomorrow?
What is 10.4?
Which is the one that we were skipping?
Well, I need to see the table of contents. You know, in front of the book. So I asked you guys to review 10.2 on your own, graphing polar equations. I'm now on 10.3, the calculus of polar coordinates. Tomorrow I will discuss conic sections in 10.4, but in 10.4 I'm not going to discuss math 29 or math 12 conic sections. You already know that. I want to talk about polar representation of conics. That is an extremely, extremely short discussion. Certainly no longer than half an hour. And then the rest of tomorrow, we just have off completely. I'll do whatever you want.
So, which of these chapters or sections in 10 are we actually going to be tested on?
10.1 and 10.3.
10.1 and 10.3?
Now, I gotta admit, you guys, I'm very unhappy with 10.1. I might write some more homework exercises today before I leave and post them on the homework page.
And so 10.2 and 10.4 we're not going to be tested on?
No, I disagree completely. 10.4, like I said, is gonna discuss tomorrow.
Okay, so, well, I asked which sections out of 10 are we going to be tested on? Are we going to be tested on every
Everything
single
but
one
two.
but 10.2?
Don't take that the wrong way. I'm not gonna ask you a direct question from 10.2, which is sketch the polar graph.
Yeah.
But I can ask a question like, well, compute the area and provide me with the graph. You still have to graph it, I'm just saying, I'm not gonna ask you a direct question out of 10.2. Because I just think that's a trigonometry question.
Okay.
Yes, Sean?
So for this one, can't we argue symmetry and
Oh,
the
tons.
whole area?
Yeah, to cut the whole area, you can just easily say, you know, the symmetry is respect to the x-axis, just compute half of it. Yeah, I was asking even a smaller question, wasn't I?
Yeah.
A much smaller question. Well, you guys check this out. Compute the area of the bounded region that is outside that, but inside. R being equal to -9 cosine theta. What does that graph look like? It's got kind of
So, he asked about symmetry on this one, but we can't use symmetry right because the graph actually crosses the y-axis, and because we were going from pi halves to pi.
Now, I admit, I'm not using symmetry to answer that question, part 4. I'm just saying, there happens to be symmetry with respect to the x-axis. So if I asked you to compute the entire area within this polar graph, you could say, I give up. I'll only do half of it, from 0 to pi, and double the result. But I know, Tyler, that doesn't pertain to my question. In my question over here, symmetry had nothing to do with it, because I only wanted the areas they had spanned from pi halves to pi. I agree. You guys look at my question. I'm cheating, again, beating that clock. I got the first one graphed already. What does the second one look like? You guys just don't want to play anymore. Yeah, I think it's a circle. I think if you have an equation of the form r equals 2a sine of theta, or r equals 2a cosine of theta, you're just dealing with a circle of radius a. Pass through the origin. It's cosine, so I'm spanning out about the x-axis, but the negative x-axis. And so I think, in red, oh no, already got red, let me get rid of that. So I think the curve probably does something like this. It's a circle. Again, I'm being very quick, I could be a little off with my picture. And I think the area I'm trying to seek is the area here. It's outside my Lima zone, and it's inside my circle. And you guys know how to graph all the other ones too? Could you do this in your head? What does that graph look like?
A rose.
I think this is a rose. And this is a rose. This has 8 petals, this has 3 of them. But I think this is a cardioid. You see the cardioid, right? You walk in the Guitar Center, you can see images of cardioid microphones.
Yes.
So you can graph basic, right? Good. And that being the case, let's do it. Oh, I can't. Shoot. I only talked about the area of within some kind of polar graph. I didn't talk about the areas in between. But it's easy. Call it R's of 1. And take away the area from the same value for alpha and beta for the other function r and theta. Or how about writing this as a single integral? Doesn't this simply look like 1/2 the integral from alpha to beta of r1 squared minus r2 squared, and we're gonna integrate with respect to theta. You don't have to listen to me. You could have just computed this one integral, computed that one, look at the difference, you get the same darn thing. I'm just conveniently writing it as a single integral because I can, because my bounds are the same. Oh, shoot, I guess I can't answer my question. I don't know what the bounds are. I don't know what those intersecting values for theta are. I need to take a break, pull out a nifty piece of scratch paper, and find out where those two curves intersect. For sure, at least for what values of theta do they intersect. Oh no, I'm fading again. To find those values, let me take the output of one function. Is that 2 minus? Jeepers. Ay, ay, ay. I said, is that 2 minus? Pens don't want to play either. Is that 2, thank you, minus 4 cosine theta being equal to negative 9 cosine theta? Does that mean cosine of theta is equal to negative 2/5? So theta is equal to
Cosine inverse. 2/5.
say again.
Negative 2/5.
You trigonometric experts. 2 pi minus inverse cosine of negative 2/5. Do I need to check the chart list out there, make sure I walk the right class again?
Where'd you get the 2 pi?
Do this. Certainly this angle right here is the inverse cosine of negative 2/5.
Yes.
This one down here is going to be 1 full revolution backed up by the inverse cosine of negative 2/5.
Symmetry.
Okay, now that we're on a roll, let's come in and set up our integral. I think to set up our integral, I have that my area is going to be my 1/2 times the integral from, is that inverse cosine of negative 2/5 to 2 pi minus inverse cosine of negative 2/5.
So is that different from just minus cosine? Because 2 pi is 0, right?
You know, I think it is for this reason. I mean, pictorially speaking anyways, maybe not computationally, but in terms of my picture, I'm spanning from this position to this one. I'm rotating in the counterclockwise direction. And you're rotating in the clockwise direction. I'm just trying to be careful with my angles. By the way, sir, in the end, I don't really care. Watch. Can I put a squiggly line? I would never do this. I would come and say, oh, the heck with it. Let's just integrate from the inverse cosine of negative 2/5 up to pi because of so much symmetry, and let's double the result. To be perfectly honest with you. And that's what my next step is going to be. Alright, so I flubbed it up. I forgot the squiggly line in green. I'll put it in. I think I've got the outer radius squared, which is, I don't remember. Is that 81 cosine squared of theta minus the inner radius squared, which is 2 minus 4 cosine of theta quantity squared, and I'm going to anti-differentiate with respect to theta. All right, you guys, I need some more honesty. Is that a piece of cake to evaluate?
Your 1/2 disappeared.
I know because
Oh.
I cut my integral in half and doubled the result.
I don't know about those first.
Because I'm nervous with this one. Do you think I can finish? I'm kind of worried that there's some things missing in your background. You're just being way too quiet. Can I actually finish this example? Because I got time.
Yeah.
And in finishing this example, I've got the integral from here to here of stuff. Let's talk about the stuff. to make sure my math skills are correct. And I think that gives me the following. Does that give me the integral from here?
Isn't the first one positive?
Is it? Did I make a mistake? You're right, Sean. It is. Thank you. Positive 81 minus 16 is a positive 65 like I had it originally. Up to pi. Oy, oy, oy. Are you guys still checking my arithmetic? And if you are okay with my arithmetic, let's anti-differentiate. I think that gives me 57 pi. Excuse me, 57 halves theta, not pi. Anti-differentiating cosine, does that give me is that a positive 1/4 sine of 2 theta? And is that a positive 16 sine of theta? And I'm going to evaluate from here to here. Oh, excuse me, I misspoke. I meant from here to here. But I think that gives me the following. Is that a 57 halves theta plus, I got an idea. Let's rewrite it. In terms of theta.
1 over 2, sine of theta, cosine theta.
Times-
Plus my 16 sine theta. And by the way, I'm evaluating, I forget, from here to here. But I think that's going to give me the following. Evaluating is the antiderivative of the upper bound of integration, 57 halves pi. Plus 1/2 times 0 times negative 1. Plus 16 times a piece of cake, 0. Minus this antiderivative evaluated lower bound of integration. Sorry, Mario. Let's be a little careful. I think this evaluated lower bound of integration is simply going to give me my 57 halves times the inverse cosine of negative 2/5. My next term is going to be 1/2 times the sine of the angle whose cosine is negative 2/5. Can you guys tell me what that is? I always feel so alone in here.
Just drop the triangle.
We can't hear head from.